Okay, number 46. All right, so we got a bunch of resistors here. A bunch of resistors. The first thing they want us to do in this problem is find the equivalent resistance of the circuit, which simply means we take all of these resistors and simplify them into one. So to do this, you're going to start away from the battery. You're going to start over here on this side and work your way back towards the source of the current, which is the battery. Okay? So looking at this diagram, notice that the 3, the 4, and this 3 are in series, because as the current moves through these 3 resistors, the current, like starting here at point A, so once you leave point A and you travel through these 3 resistors, there's no branching. So these 3 resistors, the 3, the 4, and the 3, are in series, and the way that you simplify resistors in series is you add them up. So 3 plus 4 plus 3 is 10. All right, so here's what I'm going to shrink this down to make room. Can you guys still read that? Is that too small? You can still see it. Make it a little bigger. Okay, so the next picture is going to be like this. So I'll do it big. All right, so there's the battery. We got that. We got that. We got that. And then it goes like that. And then down like that. And then like that. So we got 5 ohm, 3 ohm. Okay, now, wait, did I do this right? Hold on a minute. That's 10 ohm. That's 10 ohm. That's 3. Okay, so we need another one. So bam, like this. There's our 2. That's a 4. Okay. Now, look. Who is this guy right here? That guy that I just circled is the 3, the 4, and the 3 simplified, which we said is 10. Okay, so here's our new picture. Now, next thing, what are we going to do? Well, check this point out right here. What happens at this point right here, that dot? The current splits, so that means that these 2 resistors here must be in parallel. So the way you simplify resistors in parallel is you do the 1 over equation like this. So 1 over 10 plus 1 over 10 is 2 over 10. So you flip that, right? Because we don't want 1 over the equivalent. We want the equivalent. So the 2 10s, that will simplify to a 5. So redraw the whole thing. Let me shrink this down. The key to doing circuit problems, the biggest thing I can teach you is to draw simplified pictures. So that's our next picture there. Okay, so moving along, try to do this quickly. So we got that, that, that. Okay, so this is 5 ohm. This guy here was 3 ohm. This guy here is 2 ohm. This guy here is 4 ohm, 28 volt. This guy here is 10. Okay, so this guy here is 5, right? So this 5, who is that guy? The 5 ohm, it's these guys, right? The 2 10s are equivalent to the 5. Easy enough? Okay, so now what do we have? Now we got 3 resistors that are in series. We just keep simplifying. Right? Not too bad. Stick that up there. Okay, so the 3, the 5, and the 2. What is that? Oh, no, that's a 3. The 3, the 5, that should be a 3. These guys are in series. No. Oh, no, it is a 2. It is a 2. That's a 2. Okay, so 3, 5, 2, so that adds up to 10, right? Those 3 guys are in series, so our next picture is going to look like this. (28 volt), 5 ohm. That guy's 4. This guy is 10. ohm. And then we got like this. So this guy here is going to be what? 10. They're in parallel. So 2 10s in parallel. Going to simplify to a 5. We're almost done. So we got 5 ohm, and then that's going to be 5 ohm, 4 ohm, and then our final picture. So now we're left with these are 3 resistors in series. So we add those together to get our final picture, which is 14. Okay, that was a lot of simplifying. Okay, oh, hold on. So the answer to question A is this, 14 ohms. Now, part B, find the power dissipated by the entire circuit. So guys, here's where you're going to use your power equations. There's 3 power equations. I'll write them here at the bottom. P equals I delta V. That's the one I told you to memorize. And then you can figure out the other 2 by substituting in Ohm's law. If you substitute in Ohm's law, you get P equals I squared R and P equals delta V squared over R. Of those 3, the one, like if you look at this picture right here, so this picture represents the entire circuit, right? The entire circuit simplifies to a 14 ohm resistor connected to a 28 volt battery. So let's just use this power equation to find the power of the whole circuit. All right, so look, 28 volt battery, that means 28 volts and 0 volts, right? So how many volts over here? 0. How many volts up there? 28. So how many volts are across this resistor? 28 volts. So using this power equation, we got 28 volts, but make sure you square it, right? The equation says square it. 28 volts, that's the delta V across the 14 ohm resistor. So this gives us 56 watts. So that's the power of all of these resistors added up. If you take the individual, you know what? If you had a lot of time on your hands and you wanted a little physics challenge, go back to this diagram, and you'd have to do a lot of work here. It wouldn't be easy. But calculate the power of all of these individually. If you calculated the power of all of those individually, what would it add up to? 56. All of them together would add up to 56. It'd be a pain in the butt, dude, to do that, because you'd have to figure out, like, you know, like let's say you wanted the power of this guy. You'd have to find out either the current through that guy or the voltage across that guy to find the power. All right, last question. What is the current in the 5 ohm resistor? Now look, is this easy or hard? It's easy, dude, because look at, why is this easy? Look where the 5 ohm resistor is. It's the very first resistor, right? So see the current going through the 5 ohm? What is the current going through the 5 ohm? It's the current out of the battery. It's the same as the current in this picture over here, the most simplified. If we can find the current in this simplified picture, then we found the current in the 5 ohm. Does that make sense? Because it's the current out of the battery. So how do we find the current in this most simplified picture? We're going to go I equals delta V over R. What's the voltage across this resistor? 28. What's the resistance? 14. So this gives us 2 amps. So if the current in this picture is 2 amps, that's the current out of the battery, 2 amps. So we have the current in the 5 ohm. You're not going to use this picture to find the current in the 5 amp. You're using the most simplified picture to get the current out of the battery.